November 7, 1631. First transit of Mercury. A transit is when one astronomical body passes in front of another. When Johannes Kepler was preparing tables of celestial events and planetary positions for the years 1629 to 1636, he paid special attention to any possible transits of Mercury and Venus in front of the Sun. With the invention of the telescope, Kepler believed it would be possible to definitively observe a planetary transit. He calculated a Mercury transit for November 7, 1631. Kepler was not too sure about his calculations, so he urged astronomers to also observe both the day before and the day after. Kepler died on November 15, 1630. The next November astronomers eagerly awaited the transit. There was poor weather in Europe, so only a handful of astronomers saw the transit. About 9 a.m. on the 7th, just a few hours off from Kepler's prediction, a small spot started to move across the Sun. All who saw it thought it was a sunspot at first, because the then accepted size of Mercury was much larger than reality. However, ideas about the size of Mercury, and the other planets, predated the telescope. The scale of things in the Solar System changed that day. March 26, 1859. Vulcan. From Kepler's time on, the orbit of Mercury was determined more precisely. With Newton's law of gravitation, the orbits of the planets were explained. After the discovery of Uranus in 1781, discrepancies in its orbit led to the prediction and discovery of Neptune in 1846. French astronomer Urbain Jean-Joseph Leverrier began work on the Uranus problem in 1845, and on September 23, 1846, he asked Johann Gottfried Galle of Berlin to look for the planet. Galle discovered Neptune that evening. With Uranus solved, Leverrier turned his attention to the other big discrepancy in the Solar System, the advancement of the perihelion of Mercury, where Mercury is closest to the Sun. This point moved, and adding in the effects of all the other planets explained most but not all of this movement. Leverrier knew the solution. There was another planet inside Mercury's orbit. On March 26, 1859, Edmond Lescarbault, a French physician and avid amateur astronomer, saw a spot cross the Sun and took detailed notes. Lescarbault later read about Leverrier's theory about Vulcan and contacted him. Leverrier was convinced that Lescarbault had observed a new planet. November 18, 1915. Einstein explains. Precession. After Leverrier gave his stamp of approval to Lescarbault's observations, Vulcan became a heated subject in astronomy. Some claimed to have observed it. Others reported that they could see no such planet. Vulcan lost some of its luster as an explanation for Mercury's strange precession, but there was not really a better explanation available. The answer turned out to be something even more radical than a new planet. Since 1905, German physicist Albert Einstein had struggled to incorporate gravitation into his theory of relativity. In 1915 he succeeded. Gravity was not a force stretching across space as Newton had thought, but mass causing a curvature in spacetime, the very fabric of the universe. That November Einstein gave 4 lectures to the Prussian Academy of Sciences about his new theory of general relativity. In the third lecture, on the 18th, Einstein explained the perihelion of Mercury, without the special hypotheses that Leverrier had to assume. From first principles, Einstein calculated the advancement of Mercury's perihelion. He went on to figure out the perihelion advancement of Venus, Earth, and Mars, but noted that their values seemed to be so small that only Mercury's could be observed. He graciously concluded his paper, I will however gladly allow professional astronomers a final say April 6, 1965. Radar determination of day. Since Mercury is so close to the Sun, it is hard to see any surface features. On those occasions, called elongations, when Mercury was at its farthest from the Sun, the same vague surface features were always seen. Astronomers who attempted to map Mercury thus agreed that the planet probably had a rotation period as long as its orbital period. Its day was as long as its year, 88 days. Beginning on April 6, 1965, radio astronomers Gordon Pettingill and Rolf Dice used the large 305-meter, 1,000-foot, radio telescope at Arecibo in Puerto Rico to bounce radio signals off the planet. They found that Mercury had a rotation period that was 2/3 of its year, or 58.7 days. The elongations of Mercury had been occurring every 350 days. This is close to 6 times its rotation period, so Mercury was always in the same position at elongation. March 29, 1974. Mariner 10 flyby. Mariner 10 was the first spacecraft to visit Mercury. It was launched in November 1973 and flew by Venus in February 1974. It flew by Mercury twice that year, on March 29 and September 21. During its final flyby on March 16, 1975, Mariner 10 came within 327 kilometers, 203 miles, of Mercury's surface. Mariner 10 took the first close-up images of Mercury, but because it arrived when the same hemisphere was facing the Sun, it was able to map only about half the planet. However, Mariner 10 showed that Mercury is an airless cratered world. Like the Moon. It also discovered the immense multi-ringed basin of Calauries, a remnant of a huge collision early in the Solar System's history. August 8, 1991. Water ice at poles. Scientists from the California Institute of Technology and the Jet Propulsion Laboratory on this date and later on August 23 made a radar map of Mercury, specifically the side that Mariner 10 did not photograph. They used the giant 70-meter, 230-foot dish at Goldstone Deep Space Communications Complex as the transmitter and the 26 antennas of the Very Large Array as the receiver. Much to their surprise, they saw a strong reflection from Mercury's North Pole. This reflection was similar to that seen from the polar ice caps of Mars and the ice-covered moons of Jupiter. Later observations by radar and the Messenger spacecraft, see next item, showed that despite Mercury's closeness to the Sun, ice, likely brought in cometary collisions, could survive at the bottom of permanently shadowed craters. If people ever visited Mercury, this ice would be a vital resource. March 17, 2011. Messenger enters orbit after Mariner 10's last flyby. No spacecraft visited Mercury until Messenger, which became the first spacecraft to orbit the planet. Messenger, Mercury surface, space, environment, geochemistry, and ranging, was launched in August 2004 and flew by Mercury 3 times before it settled into orbit. Messenger completely mapped Mercury's surface. It confirmed the water ice that had been seen by Arecibo. It also found evidence that there had been past volcanic activity and that the planet's core was much larger than previously believed, extending out 85% of the way to Mercury's surface. Messenger ran out of fuel and crashed onto the planet's surface in April 2015.